This video will cover using date and time data in the Lubridate library. By the end of this video, you should know how to use the Lubridate library for dealing with date and time data, how to create date and time values with Lubridate. The R code that I show in this video is available on Elms, and you may want to take a minute to download it and open it if you'd like to follow along on your own. The Tidyverse provides a package for dealing with dates and times called Lubridate. While this package is part of the Tidyverse, it is loaded separately, so you need to explicitly load the Lubridate library every time you'd like to use it. Lubridate provides data types for handling dates, times, and date times, functions for creating those dates, times, and date times, functions for parsing text that contain dates, times, or date times. In addition, there's functions for incrementing or adding fixed amounts to these time values, functions for computing intervals between two different time values, and importantly, there's explicit handling of time zones, daylight saving time, and a variety of calendars. So let's discuss some advantages of the Lubridate library and its method of handling dates and times. Under Lubridate, all date and time values are sequential. So adding one day to December 31st, 2017 gives you January 1st, 2018. Likewise, adding 1 minute to 6:59 p.m. gives you 7 p.m., just as you would expect if you were doing this on a clock or a calendar. Importantly with Lubridate, the values stored in dates, times, and date times are actually independent of the specific calendar or clock you're using. That makes it easy to convert date and time values between different calendars and different clocks or different time zones. And operations or logical tests on date and time data lead to identical results regardless of the calendar or the clock that's used to encode a specific value. How does this work? With date time values, every value in Lubridate embeds a time zone. By default, it's UTC, or Universal Coordinated Time, but this can be set to any time zone. Differences between two times are always going to reflect the absolute difference in time between the two moments that are recorded in those values. This makes dealing with time zones much easier. So how do we use Lubridate? It creates values of dates, times, or date times from text. Because there's more than one way to represent a specific date in text form, you always need to be explicit about the format when reading dates. So for example, if I have the piece of text 04-07-2017, does this mean April 7th, 2017? Or does it mean July 4th, 2017? These are both perfectly valid interpretations of that date, and so you need a little bit more context to get it right. You're going to create date values in Lubridate using functions like YMD. The nice thing about Lubridate is you can change the order of letters in that function to tell Lubridate how to interpret the date. So YMD is going to assume that you're giving it a piece of text where the year is the first number, followed by the month, then the day. Alternatively, the MDY function assumes that you're feeding first the month, then the day, and then the year. Lubridate functions can handle month numbers or month names, and the 3-letter abbreviations for months. Written out text representation of day numbers or years don't work so well. Let's look at some examples of using Lubridate. Remember, the Lubridate library is not loaded with the Tidyverse. If you'd like to access Lubridate functions, you need to load that library explicitly. I'll do that here. Let's create some date and time values. You create date values in Lubridate using a 3-letter function which combines the letters Y, D, and M in the order those pieces of information appear in the text. So in my first example, I use the MDY function. My text is 10/8/2018. R should interpret this as month 10, day 8, year 2018. I print out the value and it gives me 2018 10/8. By default, R is always going to print out dates in this format, starting with a year, followed by the month, then the day. Alternatively, if I gave that exact same piece of text to the DMY function, R interprets the first number as the day of the month, the second as the month, and the final as the year, which means I should get August 10th, 2018, which you can see I get here. The Lubridate functions can handle both full names of months as text or the 3-letter abbreviations. Here I give October 8, 2018 with October written out in text and a comma after the day, specifying the MDY function. R still knows how to interpret that. It knows that it's October 8th of 2018. Remember, one of the interesting things about date and time data is some combinations of values don't form valid dates or times. Here I try to use the MDY function to interpret the date April 31st, 2018. April only has 30 days. April 31st is an invalid date. If I attempt to parse that, R gives me a warning that it says that it's unable to parse the number, and instead of giving me a date, it gives me the value NA. Lastly, remember that R can interpret month names, but it has a hard time with other pieces of text. Here I've typed out October 8th with 8th in text as well, 2018. Lubridate gives me a very bizarre interpretation of that. The next data type in Lubridate is the time type. Again, Lubridate will make time values from text. Times are just hours, minutes, and seconds. So here the functions are of the form HMS, where H represents hours, M represents minutes, S represents seconds. You can remove letters from these functions if you don't have that type of information. So for example, the HM function will read a piece of text where time is in hours, the minutes are in there as well, but there are no second values. R is going to store this information as a period data type. You're probably not going to use these very often, but you might encounter them, so we'll work through a few examples. We'll look at just a couple examples of time data. First, I'll use the HM function. Here I take HM of 5:27, and you can see R interprets this as hour 5, 27 minutes, and 0 seconds. Next, I'll use HMS on a little bit more complicated piece of text that has seconds and fractions of a second, and you see here that I get 5 hours, 15 minutes, 9.67 seconds. The last important data type in Lubridate is the date time. Remember, this combines a calendar date with a time of day in a single value. You're going to create date time values with functions along the lines of YMD underscore HMS. The same rules that applied to the YMD date function and the HMS time function apply here too. So you can change the order of Y, M, and D, and you can remove components of H, M, or S. Let's construct some date times. In my first example, I use the YMD HMS function. R is going to look at that piece of text, interpret the first number as the year, the second number as the month, the third as the day, then followed by hours, minutes, and seconds. And you can see the resulting piece of text that I get is 2018, October 8th at 10:43 and 15 seconds in the morning. The UTC is the time zone that's associated with this information. We'll talk more about time zones in a minute. In my next example, I have the month first, followed by the day, then the year, and the time only has two components, an hour and a minute. To read this piece of text, I use the MDY underscore HM function. Again, you can see the resulting output gives me October 10th, 2017 at 6:15 in the morning. In my last example, I changed that piece of text slightly by adding a PM after the time. AM and PM times are different. Lubridate is smart enough to recognize this. The resulting time that I get is October 10th, 2017 at 18:15 UTC, which is 6:15 in the evening.